Hey guys, this video is for acid-base solutions, the pHet simulation that you're going to be working on this week. So we'll just go over a brief overview of what the simulation will look like and how you can answer some of these questions. So first thing, we're just going to go ahead and open this in Safari, which I have already done. So if we just go there, it should open up like this, and we're just going to click on Introduction to get started. So just looking at this real quick, we can kind of see on the right side we have different solutions, and we have a molecular view on the left hand side showing what the elements look like. So here's water. You can look at strong acids, strong bases, and weak bases. So as you move throughout the different solutions, you want to pay attention to what is changing, as well as the chemical formula or chemical equation you see at the bottom of the molecular view. Speaking of views, we can look at it in terms of molecules as well as with the solvent, which in this case is water. All right. We can also look at it in terms of a graph. We can look at different types of acids and bases and how basically how much concentrated they are in the solution. And we can just kind of hide it. Also, if we look at the toolbox on the bottom, we can look at the pH. So this thing you could just grab and hold, and you can basically put it in the solution. It will tell you the pH of the solution. So water, we know water is neutral, so it should be at 7, a pH of 7. If we go to strong acid, we can see that number goes really far down, right? Because strong acids are closer to 1 and 2. And so that's a really acidic solution we have. So again, you just kind of move that up and down. We also have litmus paper. So we have a color key on the left. We have our litmus paper you can drag and drop or hold. And you can see if we put it in the solution, we get a color. And this is a strong acid solution, so if we compare it to our color key, we can see again that's around a pH of 2. If we switch to weak acid, we can kind of see we get a different color, one that's closer to 4, 5, or 6. And the last one, this is my favorite. This is the conductivity meter. And so what we want to know is that strong acids and strong bases, we want to see how conductive they are. And if we look at water, for instance, we just drag and drop this. Okay, it gives off a small light. That's because water barely dissociates in aqueous solution. If we go to strong acid, there's a lot more ions in there. And what do we know about ions? Ions can create an electrical conductivity by having those electrons move throughout it. So if we do it, it goes, wow, it goes Super Saiyan. The light bulb is very bright, right? We can kind of see how it just kind of lights up. We go to weak acid, kind of see, okay, it's fine, not too great. But strong acid, we really get a strong light. And again, that's due to the amount of ions in the solution. So that was a brief tour of the pHet simulation. When you're answering these questions, the first page is basically just a pre-lab. You don't necessarily need the simulation to answer these. Okay, but we do want to kind of talk about some different things that past videos have talked about, and we kind of want to double check that we have. So for number 1, we can see an unreacted acid, or one that hasn't dissociated, is HA, and it's got that small white circle inside the big black circle. An acid that does dissociate has one acid or one anion, should say anion, and one hydrogen ion on its own. So if we look at beaker C, for example, we can see all of these guys. These are all unreacted acids. And this, we have one anion and one hydrogen ion. So if we talk about this, is this a strong acid or a weak acid? This one has to be a weak acid, right? Because these guys are only partially dissociating. Remember, we talked about how a strong acid fully dissociates. Weak acids only partially do it, right? So if we look at something like, let's see, beaker A, we can see that the two molecules that are in there have completely dissociated. So this one's probably a strong acid. And you can do that for all of them, right? We can see or make inferences which ones are strong acids, which ones are weak acids. And that'll help you answer the questions 1A, B, and C. Right? Also, we want to think about our pH scale. So 1 to 14, 7 is neutral. So be careful. I see a lot of mistakes on this where the number goes down and sometimes they think it's more neutral. That's not the case. Anything closer to 1 is going to be acidic. Anything closer to 14 is becoming more basic. So just be aware if it's going from 7 to 14 or 1 to 14 really, it's basic. If it's going down or the number's decreasing, it's becoming more acidic. And that goes into question 2 as well. So for the pHet simulation, the questions, it just basically asks you to go over the conductivity, the molecular view, pH, bar graphs, all of that we see in the video. And we want to just compare strong acids and weak acids. Okay. And then on the last page, we have images from a strong acid solution. So we can see the conductivity here, you can see the pH test, you can see the bar graph. So really we can just use this to compare strong acids to weak acids, right? We want to be able to go to weak acid to see how it's different from a strong acid. And again, these are just basically comparing and contrasting the two. So that's basically it. Just play around with the simulation, get used to it, make sure you have an understanding of it before you start answering the questions, and I will talk to you guys later.